Next, we're going to try converting from base 10 to a different base. And this process is going to be the same thing we were doing with the Babylonian and Mayan numerals. So to change a number from base 10 to a different base, we're going to divide the number by the highest power of that base that will go into the number. Then divide the remainder by the next smaller power of the base, and keep repeating this procedure until the remainder is less than the base. In a sense, you would end up dividing by 1. Now the answer is listing all the quotients from left to right with the last remainder on the far right. And then don't forget to add your base at the end. So if we want to convert 406 to base 8, the very first thing you got to do is write out the positional values and go so that it's one more above this. So we see 406 here, and if we were to write 1, 8, 8 squared, 8 cubed, we get 512, which is too high. So actually, we only need these three place values to represent this number 406. Okay, so we know our final answer is going to have 3 places. So we're going to start by dividing the number by the largest place value that will fit into it. So 512 didn't, meaning we're going to divide by 64. So we're going to do 406 divided by 64, and that gives us 6. So we have 6 groups of 64. We're going to find out how many are left over. So we go 6 times 64, which was 384. And we see how many are left, so we subtract. So 406 minus 384. And we have a remainder of 22. So now what we want to do is take that remainder and divide by the next smaller place value. So we already did 64, now we move on and divide by 8. So we'll say 22 divided by 8. And we got 2. 2 times 8 is 16. We're going to subtract there. 22 minus 16 is 6. Okay, now we're going to take that remainder and divide by the next smaller place value. So we already did 8, meaning we're going to divide here by 1, and that's just going to equal 6. Now your final answer is going to be listed right across the top. So we have 6 groups of 64, 2 groups of 8, and 6 groups of 1, and the final number is 626 base 8. So very important that we don't read this as 626 because we don't have 6 100s here, we have 6 64s. So we just say 626, and then don't forget the base 8. If we don't have the base 8 down there, then this wouldn't be a number in base 8. Alright, let's try example 2. First thing you have to do is write out your positional values up to, but not past, the 273. So just start way at the right here, and we know it's going to be 1, and then 3, and then 3 squared, and 3 cubed, and 3 to the 4th, and 3 to the 5th. Wow, how are we going to tell what's going on here? Well, one thing you can do is with your calculator is just start multiplying by 3's. So we have 3 times 3, and that's going to be our 3 squared, which is right here. So that's going to be 9. And then all we have to do is go times 3 again, and that's going to be 3 cubed, or 27. And then times 3 again. That's going to be 3 to the 4th, you can see that there. That's going to be 81. And times 3 again. Okay, so you can see 3 to the 5th, and that's going to be 243. Now if we multiply by 3 again, we would go above 273, so we don't need to do that. So your place values are 1, 3, 9, 27, 81, and 243. So we're going to take our number 273 and we're going to divide it by the largest place value that goes in evenly. So that's going to be 243. And we know that's going to go in one time. We'll be left with 243 here, and then we'll subtract, and we get 30. Now whatever that remainder is, we divide by the next larger place value. So we've already done 243. Now we need to move on and divide by 81. You'll notice here that 81 doesn't go into 30, but we still need to account for its place. So we're saying we have 0 groups of 81. So what you do is just carry that 30 right on over and keep following the procedure. So we divided by 81. Now we're going to divide by 27. Okay, now it is going to go in evenly one time. So 1 times 27 is 27. We get 3 left. So we take this remainder and divide it by the next smaller place value, which is 9. So we're going to divide this by 9 here, and we can't do it. So we have 0 groups of 9. Okay, and then dividing by the next smaller place value, we divide by 3. And that's 1 there. And our remainder is 0, but we have to make sure that we divide all the way out down to dividing by 1. And that's 0 left over. Okay, so our final answer in this case would be 1, 0, 1, 0, 1, 0, base 3. Now what you notice here, when you convert to a smaller base, you're going to have a lot more zeros happening here, and the number is going to get spread out. All right, let's try our next one. Convert 558 to base 12. So we need our place values. So the first one is always going to be a 1, and then a 12, and then a 12 squared. So 12 squared is 144. And then 12 cubed, so times another 12. And it's 1728. Now our number is only 558, so we don't actually need this place value. So up to without going over is what we need. So here we're going to take our number 558 and divide it by 144. We'll use our calculator for this one. 558 divided by 144. Okay, so there are 3 groups of 144. And you're going to be 126 left over. So what do we divide by next? Well, the next smaller place value, which is 12. Here we can see that that 10 is going to go in nicely there. So 10 times 12 is 120. We have 6 left. And then 6 divided by 1 is 6. Okay, so we have 3 place values here, 3, 10, and 6. So we can only have 3 symbols to represent our number. So we can't write 3, 1, 0, 6 because that would give us too many places. So what we have to do is think about in base 12, remember, that t equals 10 and e equals 11. So instead of writing 3, 10, 6, we actually write 3t 6. And then we finish it off with base 12. So anytime we're converting to a base higher than 10, we got to keep our eye on using those letters to represent the numbers 10 and higher. All right, in our next example, we have converting 4,361 into base 60. Okay, so if we were going to do this, we would have 1, 60, 60 squared is 3,600, and if we go any larger, then it won't work. Now, we're not actually going to complete this, because to do this, we would have to have 60 symbols going from 0 through 59. Now we don't even have that many letters in our alphabet. We would have to come up with other symbols to do this. So this would actually not be feasible to complete. Now example 5, I want you to do this all on your own. So we're converting the number 1001011 base 2 into base 4. So we can actually convert a base 2 number into a base 4 number. What you're going to do is first convert this into base 10, and then convert that base 10 number back into base 4. So this becomes a two-step process. Go ahead and pause the video and try this out and see if you understand this for yourself. Alright, welcome back. So let's see if you followed this progression. If we want to change a base 2 into base 10, this is the one where we write out our number, and then we write out the place values beneath it, and then we multiply, and then add these guys together. So we know, changing it into base 10, we got 75 right there. Now, if we want to change 75 base 10 into base 4, we need our base 4 place values, which were 1, 4, 16, 64. And we didn't need to go any higher because then we would have gone over the 75. So now we divide by the 64. We got 1 with the remainder 11. That remainder went here. We divided by the next smaller place value, which was 16. Even though it turned out to be 0, we still need it. Then we took our 11 again and divided it by 4. We got 2. And so we had 3 left over. We took those 3 and divided it by the 1, and we got 3. And then we rewrote our answer as 1023 base 4. And that is converting base 10 numbers into other bases.